Hello everyone. As you know, electron counting is very important in our analysis to transition metal complexes and in your final exam. So today I want to introduce the method you learned before, named ionic method, because you need to figure out the oxidation state for your metal centers at first, and consider your metal and some ligands as ions. And this method may not very clear for you to deal with metal-metal bonds. And maybe it's also weird for some of you to calculate the oxidation state. So we can use covalent method. In by covalent method, you don't need to calculate metal oxidation state, and it's very clear to explain how metal-metal bonds contribute to the total electron counting. Okay, the first step of our covalent method is to know the how many electrons in your metal center. Don't calculate oxidation state of your metal center. Don't calculate oxidation state. You need only to use the group of your metal to know the number of electrons of your metal center. For example, in this radium complex, because radium is group 7 metal, so it will give 7 electrons to your final electron counting result. It is super easy, right? The second step might be more difficult. You need to figure out the types of all of your ligands. There are two types of ligands. A. Radicals, which will add 1 electron to your final electron counting result. And type B. Neutral molecules, which will add 2 electrons. It might be weird for some of green hands, so I think the key is to imagine all of your ligands neutral and to figure out whether they are stable as radical or neutral molecules. For example, for in this radium complex, uh, CH3 is if it's neutral, and it will become more stable as a radical because there is no CH3 molecule. So CH3 methyl radical is type A ligand. It will add 1 electron to your final electron counting result. And CO, phosphine, and ethylene are all stable neutral molecules, so they are type B ligands and will add 2 electrons to your final result. So all of your ligands will give 11 electrons to your final result of electron counting. And your metal center will give 7 electrons. 7 and 11 is 18. So your complex is an 18 electron compound. We can use our covalent method to deal with more difficult cases. For example, how about metal-metal bonds? You can see metal-metal bonds as a combination of two metal radicals. So it's type A ligand radicals. Each metal-metal bond can add 1 electron to your final result. And how about CP ligand, cyclopentene, which is really common in metal organics? We can work on the structure of cyclopentene. It's a combination of a radical and two double bonds. Radical is type A ligand and two double bonds, like ethylene. They are type B ligand. So in total, a cyclopentene ligand will contribute 5 electrons in our covalent method. That's all for today. So, that thanks for your listening, and you can use our covalent method to do more electron counting of transition metal complexes. Have a good day, everyone.